Hello students, this is Mrs. Brunk again. Welcome back to geometry. Today's lesson, lesson 6.2, is going to feel like a natural extension of the last module, where we learned the shortcuts for proving triangles congruent. And it almost kind of just feels like this lesson and the next could just be included with those others. And so we're just going to be adding to that list, the list that we have so far, which is the angle, side, angle, the side, 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 the side, angle, side, and the newest one, the angle, angle, side. Now the angle, angle, side and the angle, side, angle look a lot alike, and in fact they are very close with one difference. They both involve two angles and one side. Now the difference is apparent in the name, and that's where the side occurs in the triangle. When we first learned the one with two angles and a side, it was angle, side, angle, and the side had to be between the two angles that were congruent. Almost like the angles were bookends. They're holding that, that side in between them. With this new one, angle, angle, side, this is going to be two angles and a non-included side. And that means one of the sides that's not between those two angles. Okay? And so just a little different take on two angles and a side, just a little different arrangement in the triangle. But now our list is 4. We have 4 shortcuts to choose from. And so even more important now is going to be this labeling of the triangles, because we're going to have to decide which of the triangle congruence theorems listed here are is the support for saying the triangles are congruent. So our learning goal is to learn to prove two triangles congruent using angle, angle, side. So angle, angle, side theorem says this: if two angles and a non-included, so it's two angles and a non-included side of one triangle are congruent to the corresponding two angles and non-included side, then the triangles must be congruent. So they must be congruent then. So a representation of what that might look like, marked on some triangles, is, say we had this angle, and then say we had this angle and this angle congruent, and then maybe we had this side right here and this side. So it could be that, or it could be the other pair of sides. So like we could also have had instead be these sides. Just as long as there are two angles and a non-included side. It doesn't really matter which of the two non-included sides. It just can't be this one, right? It can't be the included side, because then that would be angle, side, angle. So, and it doesn't mean the triangles aren't congruent if we had that. It just means it would be by a different reason. So we just have to make sure we get that straight. Okay. So example 1 asks us to determine whether you can use the angle, angle, side to prove the triangles are congruent, and explain your reasoning. So you can see that almost identical markings on these triangles. So we've got these two angles, okay, and we've got this pair of sides, and the side is not between the two angles, so we recognize that that's not included. It's only touching one of the angles, right, not both of them. So we know that these are congruent, and so let's say we wanted to name them. Say we named this first one triangle ABC, then to match up with the corresponding parts, we'd have to call the other one triangle DEF, and the reason is by the angle, angle, side theorem. Now let's take a look at B. So this time we have this pair of angles, and we have a pair of sides. And really the only other thing we can tell for sure is that this pair of sides, the shared side, is congruent. But this is not angle, angle, side. In fact, this is angle, side, side, which we actually said we don't actually have a true angle side side theorem. There is a special case of that we're going to learn in the next lesson. But for now, we just have to say we don't have enough information. So I'd say NEI are not enough information because they certainly look like they're congruent. I don't have any facts to say they for sure are not congruent, like, they say two corresponding angles that don't end up being the same measure or something. I don't have any information like that, but I don't have enough information in the affirmative either to say they for sure are congruent. So we'll take a look at a couple more together, and then I'll give you a couple for you try before we move on to another example. So looking at C, I see they have a right angle, so of course we know those are congruent. We have angle C and angle F, and then we have that side AC with EF, and yep, that's enough. That's angle side, and the markings show that. So I could say something like triangle ABC. And let's see, A corresponds with E, so then I'll call that triangle EDF. So again, you always want to make sure you have the matching vertices. See how E and A, see there's E up here or down here and A here. Those are the matching angles. So since I called the first one ABC, the other one's going to have to be called EDF. Okay? Just make sure you get those vertices in the correct order. Very similar markings on this one. We got a pair of sides. We've got these angles that are congruent, D and B, and we have E and C are congruent. So yep, angle side, they are congruent. So these triangles are congruent by angle side. And again, if we wanted to write a congruent statement, we just have to make sure we name the triangles in the proper order. Now, they didn't ask us to do that in these questions. They just said explain. I think the markings and the statement of the theorem explains it, but if you're asked to write them in a congruent statement, then you would want to do something like we did in C. Okay, so take a moment, pause the video, take a look at E and F, and determine if you have enough information to prove these are congruent by angle side. So please pause the video now. All right, so thanks for giving those a try. Now E, with that shared side in the middle, that's congruent to itself by reflexive, we have enough information to use the angle side. But in that F, see, this is a little tricky because these actually are congruent, but the question asks you to tell if they're congruent by angle side. So these are congruent, I did state that, but instead they're congruent by angle side angle, because the only additional part I can tell for sure must be congruent in F are those two vertical angles that I marked there in the center, GKI and JKH. So they are congruent, but just not using angle side. Okay, so as has been the case in all the other lessons, we always have an example where they might ask us what additional would we need to prove using angle side. So again, they're wanting us to focus on the one with two angles and a non-included side. So I see that there's an angle marked here and here at A, and then I have this side here. So I really have two options here. I could either, so you would need either to know that angle, let's see, R is congruent to angle B, or we'd have to show that angle Q is congruent to angle C. So if I had angle R, it would still be R and B. I would still have angle side. And then instead, if I had Q and C, that still would be angle side. So either pair would work just fine. And so with B, same kind of scenario is we have two choices. Because we have two angles, and to use angle side, we just have to choose one of the non-included sides. So the one we just couldn't do is we can't do this one and this one. That one would be angle side angle. But if we picked either pair of the other side, so you'd either need that RP was congruent to, so let's see, RP would be IG. You'd have to either show that, oops, fix my congruent sign, or we'd have to show that the other pair, so that would be RQ and IH. Either one would still give us two angles and a non-included side and would work just fine. And now let's take a look at some more formal proofs. So this time they gave us all the statements, so all the facts, and we just have to come up with reasons. So our theorems or definitions or postulates or whatever that say the information that is in the statement is true. And what we're trying to do is prove that these two triangles right here, this one, ABC, and this one up top, EDC, we're trying to prove those are congruent. So the first thing that's given to us and also stated in the proof then is that AC, this side right here, is congruent to EC. So I'm marking it, and that's given. I see it right here in the given information. And then also I'm given that these lines M and N are parallel. So that's also given, two pieces of given information, two freebies basically in the reasons. And so I'm going to mark that line M and line N are parallel. So what I have to do is come up with two more pair parts. And I've got to do that by using the facts that they gave me. So they said angle D and angle B are congruent. So I'm going to mark angle D and angle B. And if you look at these lines being parallel, right? So you've got this line right here, and you got this line right here, and like that's a transversal. D and B are alternate interior angles, right? So we can use the alternate interior angle congruence theorem to show that those, in fact, are congruent. Oops. Let's see, I gotta get rid of those markings on my triangle, so I'm gonna have to rewrite the AIA congruence theorem. Okay, now the next pair that we would want to show, or that they stated, were A and E. Now, that would be these two angles right there. And those are also alternate interior angles, so we could use the same reason here, right? But what they could have also done was use this pair right here. They could have said this pair where we've got those are vertical angles, and they could have done that as well. But they chose to use alternate interior angles theorem twice. And now you can see that there's two angles on a non-included side, so these triangles are congruent by angle, angle, side. Okay, let's take a look at this one. So we've got another proof. These look like some, I don't know, like some nautical flags or something, but then they look like they're crocheted, so I'm not sure what this picture is. But anyway, so we're told that CB, let's see, CB and ED are parallel, and that's listed right there. And the AB, so I'm going to do like double tick marks on this one because it's a different set of lines, and these two are parallel. So that's given. And we're also given one specific congruent fact. We're told that CB, so that's this side right here. Maybe I'll mark the congruences in a different color. So CB and ED are congruent, and that's also given. So this, once again, is one where they'll give you the statements and you just have to come up with the reason. And what really does help you figure out what reason to list there is to actually mark the parts on the figure and then recognize what kind of angles or sides or whatever you're dealing with. So it says CAB. So CAB, that's this angle right here. And ECD. So ECD is this one right here. Well, okay. So they told us that these lines right here were parallel. And this line right here ends up being a transversal. Now this probably really helps when I highlight that. So that's a good strategy to use. But now when you look at those angles, you can tell those angles are corresponding angles. So the corresponding angle theorem says if they're corresponding in the line or parallel, they must be congruent. Then they went on to say, I'm going to change color here, they did ACB. So let's see, ACB would be this angle, and CED, this angle. And if you looked at the other pair of parallel lines, which was this line and this line, and then now that line is also the transversal. So we know that those must be congruent because they are also corresponding angles. That's pretty complicated drawing, but if you look at those markings, you can see we have two angles and a non-included side. So the triangles are congruent by angle side again. All right, final example of the lesson. This time we've got some figures graphed. And they want us to use the angle side theorem to prove the given angles are congruent. And they give us in A that angle A and D are congruent. So this looks to me like it's some sort of rotation, this figure in the coordinate plane. They didn't really ask us to tell what that was or not, but and so I'm trying to use angle side, right? So I need another, I have one pair of angles, I need another pair of angles. Well, you can tell that angle B and E are right angles. And we're not just assuming that. We know they are because the two segments that form those angles, one is vertical and the other is horizontal, and those are always perpendicular. So we've got that second pair of angles. So, I mean, we know this given information. If we were going to write more like a kind of a formal proof, we would have a table, but we could do something like this, and we could say they're right angles. So they are congruent. So we could say right angles are congruent. And we've got two pair of angles. And then what we could do is just pick one of these sides that's on a vertical or a horizontal segment, and we could just count it and see that they're the same length. So like for instance, side AB, when I count it 1, 2, 3, that's 4 units long. But see, that would be angle side angle, right? So I don't want that one. But the side BC, which is 3 units long, let me just move this out of the way. So that's 3, and then EF is also 3 units long. And now you can see that that's angle side. So since those are equal because they're the same length, now we've got angle side. So angle side congruence. So that's the reason there. And the markings show that. So again, we were able to kind of utilize the fact that it was graphed in the coordinate plane to be able to tell how long sides are. Usually you'd have to be told if they're not in the coordinate plane because you couldn't just simply count the number of units. Okay. So next, they want me to prove these triangles by angle side, and they give me two pair of angles. So they tell me that angle P is congruent to Z, and they tell me that Q is congruent to X. And they want me to prove that with angle side. Well, this can be a little tricky if we had to try to deal with one of these oblique sides. Well, like for instance, this side and this side, but then that would be angle side angle, so we don't want those anyway. Or this side and this side, well then we'd have to use like the distance formula because those are on slanted segments, right? But if instead we chose to focus on this one and this one of them is horizontal, one of them is vertical, and we can just simply count those units. So I can see that, let's see, the OQ is 1, 2, 3, 4, 5, 6, 7. And then XY is 1, 2, 3, 4, 5, 6, 7. So we now know that those sides are congruent, and so we've proven by angle side, angle side, that they're congruent. So that actually does it for today's lesson. And in the final lesson, that next lesson that we have, we'll learn the final shortcut, and we'll have a complete list of ways of proving triangles congruent. But until then, See ya. Have a good day.